Transformations. So over to you, ma'am.
Thank you. Thank you very much, Preeti. And a very warm welcome to all of you to the third session of our webinar series, which is titled Data Science and Analytics in the Urban Context. I'm really excited actually to be with you here today. And I'm hoping that this session will spark meaningful discussions and new insights on the crucial role that data science and analytics play in shaping the urban environment. Before we begin, let me take a moment to briefly recap the previous two webinars. Our first webinar, situating the idea of disruptions in the field of architecture and urbanism, was presented by Professor Sanjeev Vidyarthi and provided a thought-provoking exploration of disruptions and their impact on architecture and urbanism. The second webinar was titled The Impact of Technology on Design, Collaboration and Sustainability. This was delivered by architect Krishna Lilamurthy, and it shed light on how technology is transforming the way we design, collaborate, and approach sustainability in our built environments. Today's session, Data Science Analytics in the Urban Context, is a continuation of our exploration of the evolving intersections between technology, design, and urbanism. We are privileged to have with us Professor Aniruddha Paul and Professor Ankush Chandran with us today. A warm welcome to both of you. They will share their expertise and insights on the growing importance of data science and analytics in the urban landscape. Their presentation will delve into how data-driven solutions can support urban planning, enhance decision-making, and drive sustainable growth in cities. As you know, these webinars are a part of a larger effort to give you all a brief overview of what the Transformations 2025 conference is all about and the key focus areas we will be addressing during those 3 days. Our goal is to engage in meaningful conversations that will shape the future of urban development, sustainability, and design. At this time, I am also happy to inform you all that to get a better idea about this topic, the Collaborating School, DYPUSOA, is going to be conducting an offline hands-on faculty development program, which is titled Integrating Technological Practices on their campus very soon. The key takeaways focus on understanding emerging technologies, adopting new skills, visualizing outcomes, practical experience, and the effective integration of all these methods into the practice of architecture, design, and urbanism. So I urge you all to wholeheartedly participate in this offline training program so that you are closer to the subject of our conference. The conference steering team, Mary, will you just move on? The conference steering team plays a pivotal role in guiding the overall direction and strategic decisions of the conference and plays a role in ensuring its success and relevance in the current academic and professional landscape. The conference advisors provide expert guidance, shaping the themes and fostering key industry connections. Mary, can you move on to the next slide, please? Next. The scientific committee is composed of leading researchers and scholars who are experts in this field. And this committee will be ensuring high quality and rigorous research, which will be featured in the conference. The publication advisors, Dr. Nandini and Professor Binumol, will oversee the quality and integrity of the conference proceedings and ensure that the research and insights shared are of exceptional quality and have lasting academic and practical impact. The core committee, and we have a large one from the D.Y. Patil School of Architecture in Navi Mumbai, will manage the event's logistics and coordination for a seamless experience. I would also like to take this opportunity to share some exciting news. We have successfully held the conference last year, and the publications from that event have now been received by all of you. This was published by Taylor and Francis, and we are really happy with this achievement. And we know that it underscores the quality and relevance of the discussions that were held at VIT Vellore last year. As we look ahead to these Transformations 2025 conference, I urge and encourage all of you to participate and submit your abstracts on the themes of the conference. Mm, will you move on, Mary, please? The dates are here before you. The deadline for abstract submission is 3rd of February. I would like you to understand that this is an excellent opportunity for researchers, academics, and professionals to showcase their work and contribute to the ongoing dialogue in the fields of architecture, urbanism, and sustainability. I'm sure that today's webinar will be as engaging and insightful as the previous ones, and I truly look forward to the discussions that will unfold. I would like to acknowledge the D.Y. Patil University Center of Excellence, our conference venue. Designed by Foster and Partner, this is a state-of-art facility that supports over 3,000 students and features a 2-acre sky garden. It has earned the LEED Platinum rating and was awarded the Public Institutional Project of the Year at the ACES of Space Design Awards in 2023. We are privileged to host the conference in such an innovative and sustainable space. We now have before us the schedule of the 3 days of the conference. Next slide, please. We begin post lunch on day 1, and we are privileged to have two very good speakers from overseas who would be talking on this subject on day 1. On day 2 and day 3, we will be looking at the 4 themes and 2 tracks in each theme with 2 speakers for each track. So it is going to be a treat for all of us. We are also hoping that it will not be just a one-way talk, but we are looking at panel discussions happening on both days, where we will have all the speakers of the day coming together to have a meaningful interaction with all the participants of the conference. I urge you all to participate wholeheartedly, submit your papers, join physically for the conference, and be with us. I assure you that it will be an enriching and learning experience. Thank you so much.
On behalf of Aparna ma'am, I would like to welcome all of you and introduce you to our university, the D.Y. Patil deemed to be university, and our School of Architecture from the D.Y. Patil deemed to be university. So with 2,000 plus alumni across the globe, we are an institute with about 30 years of experience and presence. And we are also a university with an accreditation of A++. Mary, the next slide, please. So I'd like to tell you about the 4 themes and the 8 tracks. So the first theme talks about situating the idea of disruptive technologies in architecture and urbanism. This was covered by in a webinar by Dr. Sanjeev Vidyarthi. The first track talks about the evolutions of disruptions and disruptive technologies as catalysts for change. The second and track 2 talks about disruption, societal transformations, and build firm impacts. The second theme is about established disruptive technologies with its focus on collaborations and conflict. So the first track talks about contemporary disruptive technologies, what are the collaborative processes, and development of disruptive technologies, the ones we are facing right now. And the second track talks about sustainable production practices and innovations in disruptive technologies. The third theme brings us to emergent arena, the emergent disruptive technologies, and we then move towards symbiosis and sustenance. The first track is about visioning the, how we design for the future, the speculative changes, what are the challenges we may face, and innovation as a response. And the second track will talk about multidisciplinarity, interdisciplinary collaborations, transdisciplinary integrations with architecture and urbanism. Finally, we need to now acknowledge that pluralism amongst disciplines is going to hold us and development steady. The fourth theme is about case studies illustrating the employment and the influence of disruptive technologies in architecture, urbanism, and productions. So the first track will focus on technology and the second will focus on sustainability. Second one, please, Mary. If you want to get the brochure, Mary, would you please go back to the first slide? Yeah, this is the code where you can get more details. The brochure is there. And also, our website is now live. Mary, the next, please. We will just run you through the venue. So the venue is the town hall and our lecture halls in the Center of Excellence, as ma'am said, designed by Foster Plus Partners. And as part of our pre-conference activities alongside the webinars, we also successfully conducted an online FDP about advanced academic writing for architects with stalwarts training a batch of about 60 architects and faculty across the country. And we thank all of you for the very warm response. And in the same stream, we will be having the offline FDP as Jayashree ma'am has introduced. I would request my colleague, Professor Mayuresh Gore, to tell us more about this wonderful FDP which is going to come up. Mayuresh, over to you, please.
Yeah. Am I audible, Preeti?
Wow.
I'm
Yes.
audible?
Yes, yes, you are.
Yeah. Hello, everyone. So basically, we are looking at a faculty development program which is offline, where we will be giving a chance for an hands-on experience, where we are calling the program as integrated technological practices, as already Jayashree ma'am had mentioned. So it's a 5-day program which starts on the 10th of February and ends on the 14th of February, where we have Professor Dhanashri, Architect Krishnamurthy. On the first day, they are the technological experts, architects who would be describing the trending technological practices. Day two starts with the rigorous sessions of different uh, applications and different formats, where we will be having GIS. This will be taught by the professors from the engineering department of DY Patil School, DY Patil University, that is RAIT. And it's kind of like we are integrating with it's an interdisciplinary program. So these are the experts are from the engineering department, and they have been actually engaged with these applications for quite some time now. So Dr. Sangeeta Chaudhary, Dr. Prakash Andugula, Dr. Ritika Thusu, Gajanan Birajda, Professor Pramod Kasare, Dr. Pallavi Savan, and Dr. Sumitra are 7 experts. So first day is GIS, where we'll be looking at GIS in urban and architecture, its application in urbanism and architecture. Second day is robotics, where we'll be looking at robotics as hardware component, and even the programming of robotic systems, future trends in robotics, and finally at the end of the day we'll be talking about robotics and architecture. Of course, we also have our own department with robotic arm, and all the laboratories are actually being, wherever we are actually kind of conducting these FDPs, will be in the engineering department, where they have all the state of art technologies. Artificial intelligence, of course, will be looking at different modules in architectural artificial intelligence. And finally, we have augmented reality and virtual reality. Again, state-of-art labs will be provided where we have 3 to 4 modules in which you will be actually using the AR, VR and understanding the complexities behind it. So this kind of interdisciplinary program has been, kind of chiseled out for the FDP. So I urge everyone to kind of please do register and please make sure that you get the hands-on experience. Each day, different topic will give you more and more understanding of how technology is today changing the face of architecture. Thank you. Thank you, Preeti. Yeah.
Mary, can you move to the next slide? We'd also like to tell you about the webinar series calendar for 2025. So it's today we are on the 31st. In February, we will have 2 more webinars on the 13th and the 27th. And in March, again, 13th and 27th. Likewise, in April on the 10th and 24th. So the schedules will be up on our social media handle as well and on the website. And we will also be mailing it to our mailing list. The next one, please. Yeah, so over to our experts. I would like to welcome Professor Anirudh Paul and Professor Ankush. So Anirudh sir does not need too much of an introduction because he is a beloved professor for most of us and has taught quite a lot of us, including me. So Paul sir has completed his BArs from Calcutta in 1990 and his MRs from the SP in New Delhi. He is presently a professor at the Kamla Raheja Vidyanidhi Institute of Architecture and Environmental Studies, Mumbai. Through his work at the Krivya, he has been involved in research projects with various stakeholders like the government, CBO, and communities to inform and provide alternative imaginations for a sustainable urban future. He has also presented papers at conferences, organized workshops, and published in this field. He has been part of advisory government committees that inform and frame policies on architecture and urban projects. Presently, through Spark, he is working on a climate change mitigation project called Closing the Loop, planning nature-based decentralized wastewater, sewage, and solid waste systems for villages of peri-urban Mumbai metropolitan region, funded by the UNDP and European Union. Our next speaker or our co-speaker is Ankush Chandran. He's an architect and urban designer based in Mumbai who works at the intersection of digital technologies, spatial practices, and interface design. He teaches at the Kamla Raheja Vidyanidhi Institute for Architecture and Environmental Studies, where he contributes to both undergraduate and postgraduate programs through courses and electives on urban mapping, data urbanism, and digital cartographies. His independent research spans collaborations with institutions like the Charles Correa Foundation and the Aga Khan Agency for Habitat, India, focusing on various vectors of urban life and habitat. He has also employed advanced technologies such as LIDAR and photogrammetry to map heritage sites like Sion Fort and Kopeshwar Temple, and digital cartography to to capture intangible heritage in Jaipur. His most recent project, Navigating the Grid in the World-Class City, in collaboration with the University of Edinburgh, explored issues of poverty, gender, and access to services in South Asia, utilizing digital mapping, GIS, and virtual reality. He also integrates coding and AI in his work to analyze urban data and optimize urban planning and design processes. Next slide, please, Mary. Over to you. We should start
Yes, you want to
the
start?
webinar.
Yeah. Thank you. Thank you so much. Just sharing the screen. I'd really like to thank DY Patil University School of Architecture for inviting us, and the conference theme itself it seems quite interesting, very relevant. I'm going to try and share. Let me know if you can see the screen.
Ankush, the screen is visible.
The screen is with the
Black
sequence.
screen, but
Yes,
it's
yes,
visible.
Then we can see it.
Okay, okay, great. Yeah, so like was mentioned a little while back as well. Like we have seen the sort of attachment of a variety of fields to urban studies, and that's happened because over the last couple of decades we've had intense amounts of data that is being generated now. So much so that we don't know what to do with that data, right? And data has become such a powerful way of studying and sensing the city that it's important to understand practice. However, the problem is that most of the kind of work with data that architects and urban designers are used to end up being very locked to platform. You know, you might have a software that does one thing, or you might have one platform that does something, and that's about it, right? You're not able to do exactly what you want. So the presentation is sort of going to be about that. Uh, the screen in front of you. You may know it as console, terminal, command prompt, PowerShell, notebook, whatever. There are a lot of different names, right? But I'm sure everyone has used it at some point or the other. Maybe just to type to do run something, maybe just to run ipconfig, maybe you search the internet and you found some troubleshooting method like this. But what this terminal or this console does is allow you to tinker with the software, with the processes that run behind the software. What that means is that we are now able to control exactly how the data is being analyzed, being read, and how, and we can have like granular control over what is synthesized out of that data. Right. So the presentation is called Loving the Console, and it's approached through the perspective of the console or the terminal window that usually accompanies all of the platforms or softwares and things like that we talk about, right? And this console, it allows a certain kind of freedom and in freedom with data in all of its forms, whatever formats, because all the data that is available today is in a variety of formats. You have shape files, you have CSVs, you have DAT files, you have raster files, you have all of this, right? So what the console allows us to do is to manipulate it at a granular level, right? So essentially the presentation is about ways in which we interface with data. We're going to be showing you 4 projects largely, and we'll look at 3 specific stages within these projects. They are acquisition, analysis, and synthesis. And in acquisition, the presentation kind of shows how raw data is collected from urban sites, and how the terminal or the console, or just a bit of tinkering of the parameters in various platforms, uh, it emphasizes it sort of enhances the capacity of the console to rapidly retrieve data, right? In analysis, it shows how command line processes they facilitate transformations like cleaning, sorting, aggregating, all of that of data sets, and also allows us immediate feedback so that we can correct our processes through the sort of errors that it's throwing to us. In synthesis, we'll look at how the aggregated sort of outputs of the analysis and can be kind of translated into coherent, medium into insights and visual representations that reveal very critical urban dynamics. So largely, the presentation has 3 of these intents, right? First, we will look at the use of terminal as a way to interact with data through multiple examples of projects and processes. We'll encourage the sort of tweaking of our own interaction with the computer, with the cloud, with point and data. And because it's increasingly important to do that now in research and practice, right? And the third one is to sort of encourage the use of open source platforms as opposed to proprietary, locked-in, private sort of software, because they have very deep sort of control over what you can and cannot do. And usually, if they cannot do, that's a problem, right? So we'll just jump right ahead into the first sort of example of the interfacing with data, and this time we're going to be speaking about volumetric data. What that means is morphological data that kind of defines the shape and form of the city, heights and everything, right? It gives us an envelope and shell of the city. So, so this is from a study trip that we recently went at. So Paul and I both teach at KRVI. And the master's first year studio was taken to Trivandrum as part of their semester 2 project. And having already done an analysis of the place, we were looking at it through the sort of lens of SDGs and arriving at sites to study, deprivation, etc. And we had already arrived at sort of sites. And when we finally went to site, we employed various methods of mapping to understand the city, to read the place. And this is one of them. So what we did is one of the sites was Chala Market. It's a very old sort of commercial center in Trivandrum. It's been in existence for a long, long time, and it has a very peculiar, very amazing sort of fabric to it as well. So we, in addition to your typical sort of urban design mapping exercises, we there were surveys, the drawings made, the photography that's done, etc. We also employed photogrammetry, and what we tried to do was so photogrammetry is the process of taking like a ton of photographs and using them to sort of identify points and actually recreate a point cloud, which gives us a form, an actual shell of whatever we are scanning. So the first thing that you need to do for that is, because it's such a large area, right? I think this was close to some 64 hectares, if I'm not mistaken, Paul. And so it is not something that you can manage, because photogrammetry relies on there being sufficient overlaps between photographs. And we cannot do that manually effectively. It's going to be a very painful task, right? So the first idea is to automate the flight of the drone so that it can keep capturing all of these based on how much overlap I need. So we wanted a 75 and 70% overlap. And for that, so this is a platform called DroneLink that we use. And what this allows us to do is that it allows you to tweak parameters, such as depending on whatever drone you may be. So there's not locked to a drone, or there's not locked to a platform. Whatever thing that flies you have, it will have these parameters, right? Like it has a certain speed, it has a certain kind of camera, a shutter speed. And what this allows us to do is modify those parameters to suit our photography. For example, in case of our study, we use the DJI Mini 3 Pro, which does not have a rolling shutter, right? I mean, a mechanical shutter. It has a rolling shutter, which means there will be some kind of a blur unless you stop it at every point. So it allows us to code that that instruction to the drone and to the interface, telling it to go and stop at every point, which normally does not happen, right? So there are several sort of advanced calibrations that you can make in addition to the ones that we just saw earlier. So what you see in front of you, you will be seeing a lot throughout the presentation, right? This is the terminal, or this is the console screen where you actually punch in commands. And using several commands, you can kind of start to tweak, granular sort of details about this. Now, I know that we are all sort of not necessarily familiar with coding. I know we weren't, and what it's not really that hard to actually pick it up, because like I would realize is that architects and urban designers already have a sort of pretty strong idea of structure. And once you understand the structure of the code, and it's really not hard to troubleshoot. And with ChatGPT and now DeepSeek, right? Like you have immense assistance in coding, whatever language it may be, C Sharp, C++, Python, whatever, you will get the codes for it. It's a little frustrating, but you will eventually get it, right? So this was the first sort of tweak. And what that did is it went ahead and clicked tons of photos, right? So there was some, I think 786 or something photos of Chala Market with and you will notice that every photo has just a very slight overlap with the other one. So what we then do is we need to kind of take all these photos and put into a platform that will kind of run something called an SFM, like a structure from motion algorithm, right? And what that does is it will take all these photos, it will identify points in each photo and compare pairs. So if there are 768 photos, it will compare one with two, then one with three, and so on. And it will keep comparing these pairs until it kind of approximates what points may be the same, and it tries to build a volume out of it. Sometimes it's successful in building it, sometimes it's not, and you have to give it a little assistance, and we'll look at what happens. So this is the sort of assistance that we can start to use when we interface with it, right? So what you can see is you can kind of set parameters for whether you want to use the GPS data on the drone, what kind of overlaps you might want to use, your error margins, your image quality, etc., right? And this allows us to kind of tweak the input to the interface to our liking, right? And that becomes very crucial for something like this. This is what gets generated out of that. It's called a point cloud. I'm sure you guys are already aware of it by now, right? And what this is essentially, it's just a collection of different vertices, which are colored, of course, in this case. And each of these vertices is supposed to mean, it's supposed to represent a point in physical space, right? And each of those points also has a ton of data within it. We'll just see some of the kind of data. So this is a point cloud. And what you will see, sorry, my bad. Yeah. So what you see is that there are several of these points, right? And if you actually went and clicked on any of these points, what would happen is that you would start to see, data that is sort of coded into that. It may be location, it may be RGB colors, uh, and so what you see in front of you is actually a collection of points which has a ton of data already, even though they are just vector points, right? And what the software kind of tries to do is based on your input, based on what you have tweaked earlier, it allows you to classify this data. So this right now is using RGB values, and it says that if your RGB value of that dot is close to this value, it is probably going to be a vegetation patch, or it's probably going to be concrete, it's probably going to be water, right? So it kind of does that, and just the fact that you've been able to sort of get to that granular sort of base of this data allows us to have this deep of an understanding of that build form, right? Right from such a distance. And this classification sort of leads you to understand where the ground cover is, or where the built fabric is, and the vegetation kind of gets. So you get a delayered map of the city, or a three-layered 3D model of the city, in fact, right? And what that also does is creates what's called an orthophoto, and it's a perfectly orthogonally sort of overhead photo. Any Google satellite image that you see always has perspective, right? And that's because no matter where you take it from, how far you go, you will still have some degree of bend because of the Earth's surface itself. And also, even when you're flying a drone, right, there is one point that is directly below it, but all the other points will have a certain degree of perspective. So what this does is it stitches together all those directly below points so that it gives you a perfectly sort of orthogonal roof plan of the place, right? Which is of course geo-referenced also, and it is ready for use in GIS or any sort of a GIS platform that you might need to. What it also does is it does an analysis of the surface, right? So it shows a surface distribution, and you can see the different materials have been sort of detected and classified into different classes. This is some of just a closer sort of view of this. But the 3D point cloud also allows us to do a lot of volumetric analyses, right? And this is essentially trying to find profiles of your site. If I were to cut a section through the built volume, what would that be like, right? And all of this data, of course, is to scale, and we are able to get heights, widths, all kinds volumetric analyses as well, right? So you can see right off the bat, I can kind of just experiment with what that block might look like if I were to double its capacity, or how much an existing sort of large patch of garbage is taking up. So incredible amounts of insight can be drawn once you have sort of a digital twin of your site. So this one is the reason you see some of these black sort of patches. So this was flown at 100 meters, and this was done rapidly, right? And rapidly, it still takes a day to just shoot. But what this lacks is a certain degree of detail, and the kind of detail that comes in. I want to show you another project. This is the documentation of a town in Rajasthan called Navalgarh, and we'll just briefly go through the sort of processes that allowed this level of detail, right? So in this case, there have to be more checks and balances. So I have to have ground control points. So that's me kind of going around with different ground control points, and you set them up at the building, on the roof, at various places, right? These become a checkpoint so that you can kind of scale up and course correct later if you need be, right? And then you kind of fly the drone both using that map and manually, and what you end up with is again a ton of photos which have slight overlaps. I mean, significant overlaps and just slight changes. And again, using an interface. In this case, you're using Notepad, the simplest thing that you can get. Right, we're just writing a Python code using Notepad. And what we're saying is, please make sure that there's no duplicate photographs in the set that we're going to process, because otherwise that becomes a problem. Any proprietary software that you might try to do this with, it will just take whatever you're giving, right? So in this case, you're able to tweak what it takes as well. And uh, you again sort of have parameters to tweak for how the camera will align, just like you saw earlier. And what that does is it gives us a dense point cloud. And you see on the right, there are a lot of points here and shows you how many tie points have been identified. All of these are based on the kind of tweaks you make in the previous steps, right? So this is an extremely detailed, I think close to 2.2 billion vertices in this model. And what will happen is that already this gives you volumetric information, but you will use these vertices to actually make a mesh model, a 360-degree sort of 3D model that we're used to seeing on SketchUp or in Rhino or Blender. Right? So again, this is the kind of volumetric analysis that you can do on this. Again, you can see that, so this is at, so the study was done in like an SML XL scale, and this is done at like an L scale. So you can see that it's already, the detail is much better than the XL scale that you might have seen for Chala. And there is, again, like chances of going closer and getting more measurements in. And this is the process of creating the mesh model from that point cloud, right? And this is actually using a much closer, this is close to 5 meter distance and thousands and thousands of photos. And what that gives you again is, you see that there are control points that we have added here. You have all of these images and you know exactly what to tell the software to do where, and you are able to tweak the sort of 3D model that you get out of it. Yeah. What the console also does is it constantly gives you feedback. Throughout the process, you will keep getting these sort of errors. You might get getting hints and warnings. And if you follow up on these, it is super easy to actually troubleshoot the process. So you're not really stuck doing something. You might want to, alter your methodology. You might think of a new route, or you might just tweak some minor errors that come in, right? So it gives you a crucial sort of course correction method. Yeah. Again, just some this, by the way, the platform that we're looking at is called Reality Capture. It's by Unreal Engine, the video game maker, and yeah, it's a fantastic tool. This is the sort of physical model that you get. This is the most detailed one, I think, of this process in the SML scale. And you can see that the point clouds have actually now given rise to a very, very dense and very, very detailed mesh. Uh, Other than the sort of dark patches that you see here, which were not really dark, it has captured the detail of every single thing, right? I mean, you can see the kind of detail that is there in the mesh model. This would have been impossible to generate had we locked ourselves into a platform like SketchUp or even Blender, right? Despite being open source, because you need cross-platform interaction. You need some part of the process to happen somewhere else, and then you need to bring that into here, right? So you need that interaction to be able to get this level of data about your built sort of environment. Built environments are not the only thing that data assists in, especially now we keep hearing, data leaks and like metadata, data about data and how that's being misused, etc. Right? So there are a ton of ways to start sensing intangibles as well, and that's what our next projects are going to be looking at. Uh, I believe, Paul, will you be sharing your screen?
Yeah, Ankush, thanks for that. I'll take over.
Yeah.
What I'll do is I share my screen. You're closing it. Thanks. Okay. So what I'll do now is is my screen visible?
Yes, yes.
Okay. So what I'll show you is like Ankush has shown you the idea of morphology, mapping morphologies. Okay. I will show you how actually you can look at other data forms, okay, which are very critical because the thing is that other data forms need to get superimposed to build forms. Okay. And I will show you how we have created in KRVI what is called a web client. Now, the web client is a client where you can access public databases. As Ankush has already said, we are actually interested more in like looking at open source forms of data, which can be brought together. And once you bring them together, you can do knowledge discovery. Like over Ankush's morphological mapping that he has bought in, if you start getting in, let's say, data of air temperature, air pressure, okay, it can then give you like real basis for what is called evidence-based design. Okay, there you can, then you can take decisions. Okay, this is showing, this is the heat map, and this is the morphological map. This is the vegetation map. You can take decisions about what to do with surfaces. You can take design decisions. So now what I'll do is, so this is a web map that we have created and web client that we have created. How do we create this web client is very simple. Like we generally, like, I just want to, okay, I'm not able to. God, I'm not able to get to my.
You're not able to get to your.
Wait, huh? 1 second. I have to stop share and share it again. This it's not giving me access to my share entire screen. The screen has changed actually more so. Just close some programs. I don't know how this happens. Visual. Actually, this is the coding platform in which it has been created. It has suddenly closed the program. So but when starting to share the screen, it has closed a lot of these. Yeah. So this is a program which we have created, which runs the web client. This had suddenly closed for some reason, which I have not understood clearly, but I hope it runs now. It's not running HTTP. Okay, there it's running again. Okay, so what we do is, like in this program, which brings in data, we will connect to one of the live databases. Now, one of the live databases that like we will connect to is called the National Ocean Observation Service of the United States. Okay, so like this is generally their web servers which are open source. They share data for everybody, for research purpose, for everybody. And these are live, they are running now. Presently, as we speak, they're running now. And we will show you how we can actually connect to big data and we can get these data. And if we were able to connect for the Chala market area, suppose, or any other area, okay, we would then be able to do knowledge discovery. So first of all, I have connected to the server. So this is the service URL of this server. And you can see that this system actually measures these things: air pressure, air temperature, seawater velocity, because these are observing the oceans. They're observing oceans, they're observing coasts, they're observing coastal cities. So these are the data I can get. If you go to the stations, these are the stations or the sensors which we can access. These are the sensors that you can get live data from. Okay, these are also called procedures. So the procedure data is also here. So what I'll do is, first of all, the first thing you have to know when you're looking at big data, what can this server do? Now, this little bit of scientific terms, little bit of user interfaces, which we have done prepared. This is not, as we have said, this is a web platform, that web client that we have actually generated. It's not a proprietary software. So our interface is something we have made. It's basically very raw at this point, but this is something we are working on. So the first thing we will look at, what is the capability of this server. So it takes, since it's working live on the internet, takes some time, but it starts giving you what is the, now anybody who knows little bit of coding knows this language is called the XML. Okay, now XML is how data moves in the web. Web made the data moves because it requires a certain structure to moves in this format, XML format. And there is also other formats like JSON format that it moves in. These are very light formats, and they have been created so that there is interoperability of data. It's very important. Like you and me, anybody, one can interoperate with this data. So that's why it has been kept in a format which is standardized. And XML is one standardized format. So it will tell you, look, like I am able to measure these things. Like I am able to, like, I am obviously controlled by like the NOAA, the government service. Okay, it gives you what type of like aspects of data and what types of like procedures, what type of time it follows for each sensor. So that is called the get capability. Tell me the capability of this sensor. That's the first thing that it does. Okay, now what we'll do is, let us display the sensors over the American coast. Let us see the web of sensors that's there in the American coast, so that you can understand how these web of sensors work. So I press display sensor. It'll take some time. It connects to the internet to these display sensors. There you are, the sensors arrive. Okay, now let's look at one of the sensors. So you know that Houston is one of the cities which, let's say, is extremely cyclone prone. Okay, and these are the sensors over the coastal cities of Houston. Live sensors working now. Okay, let us click into the sensor. It'll tell you what type of aspects it measures. It measures air pressure, air temperature, seawater temperature. That's the coordinate for it, and that's the station ID. Okay, so if we work on we know this is the station ID, we can go into the detail of what this can do. So you can press in another yellow point similarly. Again, they measures more aspects, and you can see no end time means the begin position has started in 1973 and still is measuring data. It's giving you live data. Similarly here, so you can, each one of these, you can click these yellow points, you know their characteristic of what type of data they are giving. And clearly these are no endpoint data. So let's look at one. Let's look at the 771. Okay, so if we want data from there, so what we do is we have to go to the procedure. Okay, and we have to select 8770. So we will do that. Just let's do that. And let's see. And as I'm saying, this is live so that you can get an idea how it works. So 877077. Okay, there you are. So I click this. Okay, and what I'll do is I'll ask it to describe what is the sensor property. Okay, what can it do? So I'll just press this. So it gives me, again in XML format, it's again sharing the data. It is telling me that what can this this thing do? 87707 like sensor do. And it will give you everything. It will give you the time till when it is working. It will give you all the details. So this is the time till when it is working. If you see 25/1/31st, that's the present time. The present time is 12:37. So I'll just copy this because I want the data of this to be shared with me. So 25/01, I want this is the present time that is working, suppose. So what I do is I get this into the end time. I just paste it into the end time. Okay, 37, 34. Okay, I paste it on top also. Okay, and maybe I look for 1 day data for air temperature. So I look for 1 day data for observed property is air temperature. Okay, so now what I do is I want to look at the temperature for this filter. I have given a time filter. So I press the time filter. Okay, and it gives me, starts giving me, as you can see, this is the data which has come in Excel, XML format. Okay. And it gives the whole day data, every 6 minutes data about air temperature. As you can see, it's 16, 15, 14.9. Okay. Somebody can close their, yeah.
Neha, would you please mute yourself? Thank you.
Okay, so this is the data which comes in for the whole day. Every 6 minutes is giving you the data. Okay, now if you want to see it in terms of a chart, it'll take some time, but it'll draw a chart also. So there you are. It draws a complete chart for the whole day, and you can obviously zoom into the data points and you can understand the data which is come every 6 minutes. Now let us understand the importance of this. So you are in Houston right now. Okay, and you mapped this data point. You've got the data from every one of these yellow points that you have. And what you can do is, after that, you can interpolate and create web maps which can show you the localized heat map in this area. Okay, localized air pressure map in this area. Now imagine the power of this map when you overlay it with, let's say, Ankush's morphological layers, which is vegetation, build form. Okay, and that's when you can do knowledge discovery. In fact, working on the KRVI, as I've shown you earlier, we are working through codes like which is completely open source, nothing proprietary about it. And Ankush has explained in today's day and time, like if you just want to learn a language because there is ChatGPT with you, DeepSeek with you, okay, these are all possible for architects. These are nothing great anymore. Like you don't need to be a coder to actually put this platform together. They are very much easy and they are very much possible to be put together. So with this, I'll come to my end of my second case. So again, we'll go back to Ankush and Ankush will share the third case. Ankush, you can take over now.
Yeah. Is my screen visible?
Yes.
Yeah, you can see your screen.
Okay, great. So like Paul was mentioning, right? The Sense Lab is sort of KRVA space for all of these sort of experimental, sensing and pulsing experiments in the city. And and Paul spoke about localizing these readings for our sort of purposes, right? And this is our attempt to do that. The Sense Lab is essentially right now as a pilot is a monitoring station with these parameters that you see in front of you, right? There's wind speed, temperature, air pressure, rainfall, etc. So there's 7 of these parameters. And what we are trying to do is set up a grid like this all over K West Ward First. And the idea is to be able to place these grids in a variety of sort of situations, right? You put them in very dense concrete, you put them in green spaces, you put them in the middle of traffic, in between highways. And what you get is a sort of granular reading of these 7 vectors from all of these sites, right, which allows us to create urban heat island maps. It allows us to understand where air quality is poor at the time. This is also, in retrospect, a crucial sort of data set for planners when they're creating the next DP, right? Which are the areas that seem to get polluted most during this time of the year or this time of the day? What can we do about it in terms of land use? Can we move them somewhere else where there's a little more draft? All of these things are possible because of these kind of insights, right? And the way we've built this is again, as Paul is mentioning, these are sort of codes that are very easily generated. Slightly annoying to debug, troubleshoot, but it's just a matter of giving the right sort of prompts and being able to sort of also train the GPT you're using, whichever LLM you're using, to train that in exactly what you need. Right. So what you see in front of you, let's try get this pointer. Yeah. So what it's doing is so all of the data that comes from those sensors, it gets fed into a server that is in the digital lab at KRV, right? And it comes as, like Paul said, it comes in as XML, and we want to use that XML data in our analyses in GIS, etc., right? And there are a couple of ways to do that, and this is essentially telling the sort of there's not even a platform, right? We're just using Python. So we are importing these sort of libraries, and then what we're doing is we're defining the sensor, we're defining the parameters that it will take, and we're telling it to import it in a certain way and visualize it. What that yields is an interface like this. This is publicly available right now. I mean, we're still building it, but the data set is out there. And this is the kind of, like this is a very preliminary sort of visualization. It just plots what is, not really an analysis of it. It gives us a variety of parameters. But the data actually now, if so, that code that I showed you, that was to actually take all of that XML and put it in CSVs, like in comma separated values. And what that yields is uh, this is one sort of Excel file, CSV, and you will see all of these records, right? It yields, so the sensors right now, because we have complete control over it, the NOA, the thing is the sensors, the parameters of the sensors cannot be controlled by us, right? If they have set it to an interval of taking readings every 5 hours, it will only take that. You can't do much with it. What this allows us to do is actually tweak that time. So this is set to take a reading every 5 minutes. We can set it to every 2 minutes, every 5 hours, every maybe 4 times a day, and that yields a bunch of sort of CSV files. And it's nearly impossible to actually do pattern analysis on this manually. This is 1 year of data, and of that, a couple of months the monitoring station was off as well. So it still yielded all of these sort of entries, right? So once again, you turn to the interface, you find out what it is that it goes into each of these sort of patterns, right? So you assign. So typically, these are mathematical models that are fairly well established. You can find them even in research method books, in quant research books, or in fact, even just doing a sort of case study of projects can help you do that, right? So these are sort of very common vectors, the z-scores and anomalies, etc., right? And it uses, and this has again been generated by ChatGPT and troubleshooted by us, and like of course you have to customize it for your own system, for your own path, for your environment, but not very hard to do, right? So it generates it, and again, we're interfacing with the hardware that's installed to send us data in exactly the kind of format we need, in exactly the kind of precision we need. And we are going to be using that to understand, analyze patterns, and to try and find out if there are times in the year where it spikes up. And we can correlate that data with morphological data or with other data like rainfall data or maybe traffic accident data. A variety of things can be overlaid, and many observations can be made. So this is again turning to the interface to VS Code to kind of generate a code to visualize the analyses that we have done, right? So this is a sort of interface that was made, just like Paul showed you the interface right now. This is another sort of interface that has been made, and this is actually just dedicated to pattern analysis of the climate data that we've gotten, right? So, I mean, this is not live, this is on a local host, but the way it works is you're able to sort of filter the kind of range that you're looking for, what went up, what went down, and it will also tell you a sort of correlation factor below. I mean, it's the text is a little weirdly placed and all that in this case, but I mean, this can be tweaked very easily, right? But what it tells you is whatever you have chosen, what is the correlation factor between, say, temperature and rainfall. If it is high, then you can say that, they are mutually really, they're dependent. So this is sort of an attempt to create that kind of a sort of platform for us to be able to analyze live data that we can generate, that we can control, and we can publish. The idea is that this becomes a sort of public portal when the grids are all done, so that like you have granular data. Even the meteor stations, the government meteor stations that we have, they only have 3 of these sort of centers, right? So that becomes a little bit of an issue when you're trying to understand the micro urban sort of scale. Uh, next up, we'll talk about it. Paul will actually take you through. Do you want me to show the slides first, Paul, or do you want to share your screen first and then have me show the slides?
Ankush, I don't have, like, I don't know what is the reason. Moment I start sharing the screen, all my other coding, this thing like Docker desktop stops. Okay, can you show me the PPT, because the PPT has got the, I believe, all the compilation of the. So this is
The FTC PPT.
the yeah, Nala Supara PPT.
Yeah, yeah.
Okay, so this is a study again. The fourth thing we come for, like understand for, and we are showing you one case where we are actually using like the understanding of data science, the understanding of coding platforms to be able to simulate data also. So this is a very interesting case where we are studying the understanding of mobility among auto rickshaws. Okay, like auto rickshaws, as we know, are informally organized. They are not formally organized. Like, just let me tell you, they are not schedule driven. Whenever people come, okay, people get up the auto rickshaw. It's called a demand driven system. Okay, so collecting data about this system generally becomes very tough. Okay, so what we have to work is with more understanding of probabilities. What can the simulation be? What can the possibility be? Okay, so here again we are using Python to be able to create such simulations. Okay, so Ankush, you're there?
Yeah, I'll just share my screen.
You can share the screen.
Yeah, can you see it?
Yeah.
Okay. Just let me know when you want me to change the slides.
Yeah. So this is the like complete auto rickshaw ecosystem. It shows us 21 routes. Okay, this is the Nala Sopara railway station that we have. Ankush, you can show the Nala Sopara railway station. Okay, and then we have these routes which are there from the station to the northern side to the southern side, and one which goes to right till the highway. It's written there, highway. So there are 21 such routes of auto rickshaws that we found in like Nala Supara. Okay, and let's see the next slide, Ankush. Okay, so this shows actually where does each one of these routes from the various starting points, where does it go to? So what are the destination stops? So these actually link to that. And we had given every stop a name, okay, a code, so that we can understand and understand how these stops actually work when it comes to like these different routes. Show the next slide. Okay, so these are the 6 points near the railway station. As you can see, the yellow points are the 6 points from the railway stations where these auto rickshaws operate. So these are the 6 points from where auto rickshaws will start for various destinations. As you can see, all the destinations, all the routes are shown in blue, and the yellow are the entry points from where you get the auto rickshaw. Okay, the next. So now we like for this, what we had done is we had used complete Python as a coding platform. I could have shown you, but somehow when I'm sharing the screen, the whole coding platform is stopping. I don't know what, we'll check it, what it is, but this is the outcome of the coding thing which we did. Okay, where we are showing you these different stops and these different routes of the auto rickshaw. So that's what it shows. Next slide. So this is very interesting. Okay, so what we did was we collected data only in these 4 points, that is from 8 to 9 o'clock, 13 to 14, that is afternoon, 17 to 18. So where you see the red bands, these are the only time where we collected the data in. We collected the data in a certain format. Generally, we had collected it according to a specification which was given, which is called the GTFS Flex. Now, GTFS is already a standard format to study public transport systems. Okay, Flex, why? Because this is demand driven, it's flexible. So that's why we tweaked the idea of studying generally scheduled public transport system to make it flexible. So we collected the data only in these 4 transects that you see, these red bands that you see. then we used Python and artificial intelligence to actually simulate it for the whole day. Okay. So, and it's amazing because when we were doing the study, we imagined that we would see a morning peak and a night peak. But what we understood in these different routes, that night is the peak where everything happens. Because that's where people are returning from various points in the city to Nalasopara. And that's where the maximum traffic is. So it happens between 21 and 22 hours when the last trains are coming in. Again, it's dropping down in the night. So again, 23 hours to 0, 1, 2, 3 morning hours. It is very less because the trains are not running during the time. Okay. So these are very interlinked systems with the railway and how this system works. So this we could only visualize because we use data science to its max and we use these coding platforms which were freely available and they gave us this output. Ankush, you can show just the animation which this platforms created. So we'll show you an animation
It's not
of
there in this one,
10
Paul.
huh?
It's not there in this one, is it? Or it's only there in the
It's
other
in the
one, right?
vehicle animation, which I had shared with
Yeah,
you.
yeah. I'll wait. That's in a different.
Yeah. So we will just see the vehicle animation that it has automatically created on a possible scenario for how these autos move throughout these 20 routes. So, and it is a 10 minutes interval in which the red dots are the autos. So it's a 10 minutes interval. Now it's 2 o'clock in the night. So you can see autos. So the timestamp on the at 4 o'clock, 4:10. So every 10 minutes it is actually working and it's showing you a possible animation of how these auto rickshaws are. And that's becoming morning 8 o'clock, as you can see. You just take you through the night and see how the volume actually. And these visualization is possible through data science. As I've said, these are systems which are informal, very hard to map informal systems. And that's when you can use data science to be able to visualize such possibilities. Okay. And this is just to give you an example of how these data science in today's time can actually map systems which are disordered, spontaneous. Okay. And as you can see now, as the night is going ahead, the auto rickshaws increase over the highway. Actually, they create jams, complete jams. And this is only auto rickshaw, mind you, these are not the other vehicles. Okay, and as the morning night happens, it reduces. Okay, I think Ankush, with that, we'll stop. Thank you. I think we have completed our presentation. We'll take questions if we have.
Thank you so much, Professor Paul and Professor Ankush. So now, if you all have any questions, you can ask.
Hello. Hi. Hi, Paul. Hi, Ankush. Aradhna here.
I
Hi,
Hi.
hi.
So I had a question about this auto rickshaws and how did you get data from like air tags or something?
No. So we actually worked very closely with the drivers, with the union members.
Hmm.
Okay, and obviously we were working closely, and that's the human part of it, where we explain to them the importance of this project. We explain to them like how we will be able to like create conditions where we can create advocacy reports, and they helped us to gather these red bands of data.
Hmm.
Okay, in certain formats. These are GTFS, as I've told you, GTFS formats. Once you get it in, they are then operate on them.
Okay. But again, how were the rickshaws tagged then?
How much? I didn't
How
understand.
were the rickshaws tagged?
what about, Aradhan, I couldn't get your question actually.
How did you track the rickshaw? Like,
Okay. No, we didn't track the rickshaw.
or
Okay,
yeah,
okay. So what? That's where this Python program helped us. So this is what you see, what you saw of the last animation. That's a simulation.
okay,
That's a simulation of the reality. Okay. So all the data when it came in, okay, it created simulated conditions for their positions. Okay. So that's how because we gave it the conditions, okay, that there are headway seconds in which the rickshaw start. Okay. So it could get the positions there. We have not used any GPS device to track these red points. No. Okay.
okay.
So these are simulations. That's where this platform has helped us. The data science. That's the importance of these Python and artificial intelligence, where we actually simulated an informal system.
Okay. Okay. Yeah, that's it. Thank you so much. It was an amazing presentation.
Thanks.
Any more questions? Okay, I don't think, I mean, we all are overwhelmed with the data that you have given. So people may have
We
to,
can take questions. There's no problem. We can actually. Aparna wants to say something.
No, unfortunately I joined little late in a transit. I was, but yeah, I mean, I think the purpose of this conference to bring in these complex things together, because you're working in your lab with so much focus on the coding and data and certain uh, platforms is very interesting. And what you said that how architects and access, I think certain things what you shared is going to be really, I think I wanted some of my faculty, maybe urban design, they're doing a lot of interesting work and you have visited us. So I think there can be a lot of collabs. And you made it sound very simple. I'm sure it's through your, experiments and a lot of efforts that you have simplified it for yourself. But I think my first quick response was, I think what we wanted to achieve through this conference, bringing this seemingly distant discussions together, a difficult platform that we have created, that's had started happening. So I'm actually very thankful to you. I remember our early conversation. And yeah, I think over a time, we expose ourselves, we keep talking to each other. It's only then these things will become mainstream, sooner than later, what we think. So we are definitely going to come back to you and, maybe invite you and even Ankush. We should have some maybe discussion together with both of you. And if
Absolutely.
Jayashree ma'am is here, we can plan something during the conference itself. So that was my quick response, very
Yeah.
not so very articulated, but
I
I
think
thought,
what you said
uh,
correctly is
yeah,
something very important for us.
right.
Okay, that aspect of collaboration.
Hmm.
Okay, in fact, as you saw also, like we understand the technology needs to be more human.
Hmm.
First, we said that we want to work not proprietary platform. In fact, what
Right.
Ankush showed the console. Okay,
Hmm.
we want to
Hmm.
go as basic as that
Hmm.
go to the kitchen and make your own food. Okay, I always say there's a difference between a restaurant and going to the kitchen. Okay, and going to the console is like going to the kitchen. You can prepare your own food. Okay,
Hmm.
so and like as I'm saying today in the day of artificial intelligence, okay, we can take advantage of it, and all our students can actually use these platforms to work with data science, like evidence-based
Yeah.
design. That can be very much possible.
Right. I have one question to you because you have been working with urban design and planning projects for such a long time. How do you see in terms of how much it has impacted your work, this thing, in terms of percentage? You think that, because you spoke about the idea of informal, you're being able to actually work with the data about informal systems. So how significant shift that is, for someone like you who has worked with so many years, and how this has enabled you to take a, jump ahead or something. That's something like that I want to know.
Okay. Like I believe, like again, the question which you asked, if you ask
Oh.
my engagement with like the city, okay, and how it
Right.
has made me shape my understanding, okay, and why I like now look at informality as a very, very important aspect. Okay, a lot of it, let me tell you, are driven even by my friends whom I work with, like Sheila. Sheila now says that she's a person who's like expert in the field of informality. She's been doing work with the vulnerable communities for quite a long time. Okay, she says that informal is the new normal. Okay, and she talks about how our cities, like cities in India, cities in the global south, we have to make informalization as a understanding of informal as a theory. That's how our cities are. And like, and probably when we are looking at these notions of sustainability, resilience, we need to have much more homegrown solutions. And the to it is understand these systems. We need to make our own cities a a study area. It's not that we need to copy from the place and say that let's make our city slum free or informal, remove these informal settlements. The informal systems, as I'm learning, okay, they have lot to teach us. Okay, even when we are doing Dharavi redevelopment, and that's where I've been looking at in my doctoral studies, these fabrics, these morphologies are very important to allow certain and enable certain things like the businesses that you see in Dharavi. There is a relationship clear between these informal conditions and the businesses, and these can be revealed through data science. Okay, we are attempting that.
So what my question is, I mean, I thank you for this explanation, but my question is how working with data sciences has made you, I mean, how do you think data sciences is going to really help you further your engagement with the idea of informals, which you have been pursuing for such a long? Is it has it kind of, my question is then how it's going to really impact your study and your further work?
As I'm saying, like it is going to
Yeah.
give me much more deeper insight into
Okay.
informalities
Yeah,
and
that's what
morphologies
I'm.
of informalities.
Fantastic. Thank you so much.
Yeah.
Thank you, Ankush and both of you. Looking forward to more discussions. I think people have probably Mary, are you there? I think she's written something.
Yes, ma'am. So I think so. We can end this session. So before leaving, I want to thank everyone who attended, and I want to just project the next webinar, which is going to happen on 13th of February. It is a panel discussion on innovation to address climate change, moderated by architect Prasad Vaidya. And in the panel, we will be having architect Ashok Lal and Gagandeep. So it will be an interesting webinar. So I have shared the link to register in the chat box. So I request everyone to please register there. You will get the Zoom link for the meeting soon through email. Thank you so much.
Thank you, Paul, once again.
Thank you.
Yeah, thank you, Ankush.
Thank you. Thank you so much for having us over.
Bye-bye.
Bye.
Bye.
So, yeah.